Hello, I'm Brett Thorson, and this is a ComputeCycle Deep Dive brought to you by Activity Incorporated. Today we'll be explaining how the Onion Router, commonly known as Tor, works in the background to provide you with network location anonymity. Tor can be downloaded from their website at torproject.org in two different flavors. One option is to download the Vidalia bundle. This would be a good choice if you already have an installation of your own browser and maybe some customizations that you don't want to give up. This carries with it a bit more risk as there is more control put in the hands of the user. To reduce your risk, we recommend downloading the Tor browser bundle. This is a standalone browser that is configured to only use Tor, leaving fewer configuration options, which allows the Tor software to perform its intended function. The Tor browser bundle also includes patches that address privacy problems in Firefox. Because of these patches, there isn't a way for a user to configure their off-the-shelf browser to be as safe as the one included in the Tor browser bundle. One common assumption of Tor is that it provides the user with complete anonymity while surfing the internet. While Tor does hide the computers and networks involved in a conversation, the data the user transmits and receives while using Tor could still give away their identity. This excellent interactive graphic displaying what is hidden from whom is available from the Electronic Frontier Foundation. An example would be if you could transport yourself to a city you've never been in, you'd be fairly anonymous. However, if you start buying things with your credit card and renting cars with your driver's license, your anonymity is reduced. In much the same way, if you use Tor to make purchases with your real credit card, or you are logging into systems with your real name, you aren't getting the full dose of anonymity you might expect. So let's take a look behind the scenes of the Tor applications to see how it actually sets up the routing to anonymize your network location. First, let's build the computer we'll be using in this example. We'll need a computer, and then on that computer we'll install a network card. This computer is also going to need an operating system, so we'll install one of those as well. Last, we'll need a browser to surf the web. While Tor isn't limited to just web browsing, that's what we'll use in our example today. We'll also need a destination server that we are trying to access. On the left is the basic setup most people use to surf the internet. There aren't any VPNs or proxies, and currently there is no Tor proxy or any Tor infrastructure present. As you can see, anyone watching the traffic come out of our network connection can see what server we are accessing. Anyone along the blue line can see who sent the traffic and where the request is going. In addition to those monitoring the internet links, the server can also see who originated the traffic. For the reasons of hiding the source of our traffic from anyone watching it near our connection to the internet and hiding the source from the destination server, we will install Tor. For this example, we'll install a Tor proxy. This is software that is written for many different operating systems. For security reasons, your best bet is to install the Tor browser bundle. Indeed, these days it is difficult to find Tor unbundled, and there is good reason for it. It is easy to misconfigure and have data about your surfing leak out of the Tor system and implicate you and your traffic. So installing the Tor bundle is the best way to go. So we have Tor installed on our computer. The first thing that it does is to connect with its directory servers on the internet. These are trusted and redundant servers set up by the Tor project that list all of the nodes available in the Tor network. Your Tor proxy on your machine will download this information to use to build a circuit. Before a circuit can even be considered, your Tor proxy needs to talk to someone in the Tor network. The first thing it does is to select an entry node. Once an entry node is selected, it will exchange TLS keys with the node and establish a secure connection. The purpose of this connection is to act as an overarching communications method. At this point in time, none of your surfing data is moving around the internet. We're still a good ways away from that point. The Tor proxy on your machine establishes a node-to-node key with the entry node that it has chosen. Once this TLS connection to this entry node has been chosen, communicated with, and secured, it will then attempt to build a circuit. The first message it sends is a create request and sends it to the entry node. The entry node responds with a created response. At this point, a circuit has been created between the Tor proxy and the entry node, and a specific session key has been established just for that link. Once that has been accomplished, our Tor proxy needs to create another hot point. We'll call this our middle node. Because all Tor nodes keep a TLS key with all other Tor nodes, we'll indicate that this is already present. Our Tor proxy then sends a message to the entry node instructing it to extend a circuit to the middle node. The Tor proxy is the piece of software that makes the choice of all nodes, including the use of this specific middle node. When the entry node gets the message from the Tor proxy, it unwraps it using their agreed upon session key number 1 that only the Tor proxy and the entry node know about. It looks at this message and sees that it is being instructed to extend a circuit to the middle node. It sends a create circuit to the middle node, and the middle node responds with a circuit created back to the entry node. The entry node receives this message, encrypts it with session key number 1, and sends it back to the Tor proxy, indicating that the circuit has been extended. In this message is also a session key between only the Tor proxy and the middle node. This is session key number 2. Finally, the Tor proxy needs to select an exit node. It chooses one based on availability and certain rules. It sends a relay request to the entry node. The entry node unwraps it with session key number 1 and finds another relay request within it. The entry node sends this relay request to the middle node. The middle node unwraps this request with session key number 2 and finds another extend request specifying an exit node. The exit node is contacted, and back through the chain is sent a session key that only the Tor proxy and the exit node can use to communicate with each other. This is session key number 3. This key is also used to validate that the data coming into the Tor proxy is the same data being sent out of the exit node. We now have a telescoping set of tunnels that unwrap much like the layers of an onion. At this point, our request can be sent from the browser to the Tor proxy. There, it will wrap it up in 3 layers of encryption using 3 different session keys and send it through the 3 nodes. Each node will unwrap 1 layer of it. The first 2 nodes will only see that they need to forward it onto another Tor node. The last node will see that it needs to make contact with a website. The benefit here, though, is that the exit node has no idea where this traffic originated from. This provides the anonymity of origination. However, and this is a big however, if the traffic you sent into the Tor proxy back on our computer is unencrypted, it will also be unencrypted, leaving the exit node. If there are usernames or other identifying information, anyone listening at the exit node or on the link between the exit node and the destination server will be able to detect this information and use it as a piece of data to figure out who you are. Remember when we told you the best way to install Tor was with a browser bundle? That is still great advice, but let's look at what happens should you either not follow this suggestion or you decide to install media players, flash players, or Java on your machine. A website that is very interested in trying to find out exactly who you are and where you are coming from could send your browser a request to load a specific kind of multimedia file or ask it to run Java or Flash. This will make your browser attempt to run an external application which may not be configured to use the Tor proxy. If this were to happen, it might cause your browser or operating system to bypass the Tor proxy and request this file over the regular old internet. If you'd like to prevent ads from being served to your computer, one option is to install the Firefox extension called AdBlock Plus into your Tor browser bundle. The fewer things your browser is asked to do, the less information it will potentially emit to the world that could divulge your identity. This software does not ship with Tor natively, so it will have to be downloaded and installed manually. The way that Tor circuits are destroyed happens in much the same way as they are created. It doesn't even have to destroy the entire circuit. Your Tor proxy could just pick a new exit node. There are many other features built into the Tor software to prevent many attacks. Today we just covered the basics of how a Tor connection is actually created. Stay tuned for more videos on how Tor hidden services work and how bridge nodes work to help people in oppressed countries communicate. If you have any comments, please let us know at feedback@ComputeCycle.com, or you can follow us on Twitter @ComputeCycle. I'm Brett Thorson. Thank you for watching this ComputeCycle Deep Dive brought to you by Activity Incorporated.
We've just said goodbye, could it be for the last time?